Okay, ladies and gentlemen, we are today going to talk about our next section, which is 8.4 logarithmic functions. Okay, and we're going to get into this, talking about what logs are, how we can use them in mathematics, and the properties they possess. Notes today are a little bit on the easier side. They really are. It's really basic. It's just talking about the general overview of it. So let's get to it. All right. So to start off here, it says, how do you change a log to an exponent? Well, that's our key question. But here's a daily question. It says $500 invested at 6% for 8 years. How much money would be there compounded monthly or continuously? Okay. If it's monthly, we are using this formula. Okay. A equals P times the quantity 1 plus R over N raised to the NT. Again, I need you guys to know how to use this formula. Your P is your investment, which in this case is 500. 1 plus 6% we do 0.06. If it's compounded monthly for my n, I plug in a 12. Then raise to 12 times 8. Okay? So let's take a look at how that looks on our calculator. 500 is our principal. 1 plus, I'm going to do another set of parentheses, 0.06 divided by 12. I'm going to close it. I'm going to close it again. I'm going to raise it to the power of 12 times 8. See if I can focus a little bit. It seems like out of focus. Maybe I'm wrong, but better. Okay. And that gives me $807.07. Okay. Cool. After 8 years, you earn about $307 for doing nothing. Continuously, we use the PERT formula, P e to the RT. My principal is still $500. E to the 0.06, and my time is 8 years. Let's see what the difference is. 500 is my principal. Guys, again, my E button is second division sign, and then I can raise it to the power of 0.06 times 8. Quick reminder, I have a newer calculator here. It was the older one. I want to put parentheses around it. Newer ones don't have to. I end up with 808.4 cents. Or 0.04. Okay? Okay, so definition of a logarithmic function with base A. Now, here we go. This is the beginning of it, okay? And this, please make sure you have copied down what I'm about to write down, right? A log with base A, all right? I put a number next to it, and it's equal to x. Log base A of B equals x. Now that's all well and good. What the heck does that mean? This can be rewritten as you take your base down low. This is the base of your exponent. And you write that down first. You raise it to whatever this power is. So a to the x equals b. Alright? So the base of your log is the base of your exponent. What it equals is the actual exponent. And then the number right here is just the value that it equals. So the answer to a logarithm is an exponent. Okay? Kind of important. Kind of, I mean extremely important. Okay? So again, the answer to a logarithm is an exponent. We are just rewriting it. Now you're going to see this. It's going to take you about a couple tries to get used to it. Once you get the swing of things, you're going to realize it's just one simple move that it's really easy. Okay? So what we take a look at here, it says solve the following logarithms and write them in exponential form. All right. What I can take a look at is, you see how it says log base 2, 32, it's not equaling anything? I want you guys to put x's in here. I should have x's in here. I don't know why I don't have x's in here. So log base 2 of 32 equals x. What you're doing is, I'm rewriting this as 2 to the x equals 32. 2 to the x equals 32. Okay, again, base to the exponent equals this number. Well, now we can think about it, and you're going to play with this number a little bit. What number, 2 raised to what number gives me 32? 2 raised, hang on. 2 raised to the 5th. There we go. So my answer here is x equals 5. That's it. 2 raised to the 5th power gives me 32. I'm going down the line here. 5 raised to the x equals 625. Now again, if you don't know this off the top of your head, it's okay. Just play around with it. 5 to the second. No. 5 to the third. No. Oop, that's 2. 5 to the third. No. 5 to the fourth. Bingo. So my x here is just 4. Okay. Now, here, if you guys notice, you see how I don't have any number written? 2, 5. This one just says log. If you just see log, that automatically equals log base 10. There's a 10 down here. So what I'm going to put is 10 to the x equals 1 over 100. Now think about this. How do I make it flip? Well, I make it flip by putting a negative up there. So I know my x has to be negative. Oops, just writing down the answer well, sorry. So how do you make 10 turn into 100? Well, you square it. So my answer here is x equals negative 2. Check this out. 10 raised to the negative 2 power gives me 0.01. What do you guys think 1 divided by 100 is? 0.01. Okay, so this is another one we'll get used to after a while. Last one, 7 to the x equals 1. So 7 to the x equals 1. What can I raise 7 to the power of to get equal to 1? Well, this one should be easy. It's always just 0. Anything raised to 0 power is 1. Okay? Alright, now, I can go backwards too. So here, this one's actually kind of easier. 9 squared equals 81, which is a true statement. The 9 is the base of your exponent, therefore it's the base of your log. The 2 is the exponent. Remember, that's always your answer. And the 81 just goes in the last spot. So log base 9, 81 equals 2. These are way easier because you don't have to think at all. Here, the base is 2, so log base 2. 3 is my exponent, that's what it equals to. And the 8 goes right here. Okay. 64 is your base. Log base 64. 1/6 is my exponent. And then 2 goes right here. Don't be thrown off by letters. A is the base, so log base A. X is your exponent. And B goes right there. Huh, where's that one look familiar from? Ta-da! Sorry, I don't know. Alright. Use a calculator to graph f of x equals log base x and f of x equals 10 to the x below in different colors. What's the relationship? Let me see if I can find different colors. That'll work. Okay, so here is, you can see that. Okay, so I've got y equals, I'm going to type in log x. By the way, ladies and gentlemen, there's a log button here, and there's an ln button. These are our two biggest buttons for this chapter. I will explain it to you in greater detail tomorrow. There's log base x. Okay, if I graph it. Okay, I'm going to go ahead and just give a rough sketch of this right now. Okay, and then let's see here. The second one is e to the x, or sorry, 10 to the x. Let's graph that one. Okay. Now I know this is a little bit of a throwback, but these lines are, let me zoom in just a little bit here so you guys can see this. These lines are symmetric about a certain line, and that certain line is the line y equals x. So if I draw a line y equals x, right down the middle, they're symmetric about it. Well, what does that make them? That makes them inverses. Okay? They are inverses of one another. And this is again proving my point. I have log base 10 down here, okay, and it's 10 to the x, so they are inverses of one another. Important to point out. We're going to talk about that in more detail with different bases. You can have log base 2x, and that equals 2 to the x, log base 3x, 3 to the x, so on and so forth. Okay? Alright, so certain properties of logarithms. Let's take a look. Log base a1 equals, well, in this case, a to what power, I'll call this x for now, equals 1. Well, it's always going to, oh, I wrote down the answer again. I don't know why I keep doing that. This will always equal 0. Okay? Blow it up. Any number, if I have a base here, raised to the 0 power is going to equal 1. Okay? So keep that in mind. log base a will always equal 1 because a to the first power gives me itself. All right? Log base a to the x. Okay? What do I have to raise a to make it equal to this? Well, it's just x. Just look at it. A to the x equals a to the x. Okay? And then it works out just fine. And lastly, if log base ax equals log base ay, can you guys see how log base a and log base a are exactly the same? So what do you think x and y have to be? Exactly the same. Okay? It's that simple. Alright, now, the natural logarithmic function. Okay? The natural log is a special one, and that is the ln one. Okay? So we call this log base e, right? I'll put a here, equals x. So that can be written as e to the x equals a. Now, I got to give you guys a little heads up. Log base e is equal to natural log. Okay, so that's just, these are the exact same thing. Log base e and ln. That's why in the calculator you see ln. Okay? So you'll never guess if I go back to here. Everything's really, really dark. Clear. Clear. Let's do e to the x. And let's do natural log, which is down here. Sorry. Natural log x. I don't know why it's not working so well. It's probably not doing much better, is it? Nope. Sorry. Okay, so if you check out the graph here, and I'm running out of time, so I'm trying to go a little bit quick through this. Much the same. Okay. Oh, sorry. Different colors. Here's your green. There's your blue. There's your black. Okay. So again, inverses of one another. Okay. The exact same properties are here. Again, what's the base here? It's technically e. You're never going to see me really write that much, but e raised to what power equals 1? It's just again 0. E raised to what power equals e? E to the first. It's almost exactly the same properties above. The natural log of e to the x equals, okay, again there's technically an e here, so e to the x. Alright, so e to the x equals e to the x. And over here, if the natural log of x equals natural log of y, then x equals y. Okay? So there you go. The last part here, right, just to show you guys super quick, you can evaluate things on the calculator. There's going to be very, very few times I'll make you guys do this. In fact, a lot I'm going to make you do it without the calculator. This is the one part of the year where I'd rather you guys do it out. But just to show you guys, log 2/3, there's a log button right here. And I type in 2/3. Okay, and you do get a decimal, 0.1761. We'll go to 4 decimal places. Okay. I can go down the line. Log base 10 is the same thing as log, so you might want to make a note of that. Log base 10 is equal to just regular old log. So I got my log button again here, and I'm going to type in 4.72, 0.6739. Okay. The last two are natural log, which is just the other button. Let's see, negative 0.2877. And lastly, negative 3 natural log of 7/5. Negative 1.0094. Okay. So that wraps it up, guys. We'll talk about this more in detail tomorrow, but as always, keep up the good work. Good luck. We're all counting on you.